there is a chat feature at the bottom. If you want to send me kind of a message at the bottom, you can go in there and just type something up, and generally I can see it, and we'll reply. We'll type something to you. But let's go ahead and jump into this. Basically, welcome to our C-valve system webinar. And basically, please ignore the date. We did a trial run back in January with another rep, and I forgot to change the date. So, but other than that, why don't we go ahead and jump into this and show you what we got. For some of you that were at the ASPE show, we had one of these, and basically this PowerPoint presentation was available as well. So for some of you that saw this at the ASPE show, it's going to be a little bit of a refresher. For those of you that weren't able to make it, you know, we're going to kind of go through this one at a time. Some of this stuff is going to be very familiar with you because it's a lot of the basic stuff we already offer through our manifolds. Some of it's going to be new. We're going to start right here with our patented 800 high-low single valve valve that's in this system. Basically, guys, you know, when we decided to come up with this, we really didn't want to change too much of what we have. The valve it works well. It provides three-way protection that nobody else really has. So we really didn't want to mess with that. The other nice thing is you guys can troubleshoot it still. It's got the same guts inside of it, same thermostat, same piston and liner. So basically, if you want to repair it, you can repair it. If you want to maintain it, you can still maintain it. So that really hasn't changed. So that's the nice thing about this system is you guys are familiar with the valve. So the troubleshooting from a valve standpoint should still always be the same, no matter the application. There is what we call kind of a fourth layer of safety, or four-way protection, if you will. Basically, our competitor system, if they lose power to the building, their valve will go into a cold water bypass. Basically, they shut off the hot water flow through the valve and only provide cold water. The nice thing about our system, we will still continue to provide tepid water if there's loss in the building. If the building has gone to their backup generator or backup battery system, not only, you know, do they have some functionality in the system, but they're still getting tepid water and not just straight cold water. So again, we're kind of adding another layer there of protection, or if you will, a feature that basically our competitor doesn't have, or doesn't really have that capability to do that. Secondly, the only thing that's changed on that 800 valve is basically how we set the valve. We've gone from a mechanical set screw or a mechanical setting now to an electronic temperature setting. Basically, what we've done is we've taken the bonnet of the old mechanical bonnet off and put an electronic actuator on there that now is basically electronically moving that pusher up and down inside that valve. Again, if you lose power, the end user will not be able to adjust the temperature. But in reality, how often do buildings change the temperature? It's pretty rare. They're not doing it multiple times during the day. But really, as far as the 800 valve goes, this is the only thing that changes with the valve. Again, some of you that sell our manifold systems, you know, Grant, Darren, you guys do a really good job selling these manifold systems. You'll see some familiar stuff on here, like the circulator switch. It's still, and all this is standard. We're on our other manifold. This stuff tends to be optional. This is all standard offering. Basically, you really don't have a choice. The circulator switch is basically on there, so if they want to manually shut off the pump and do any maintenance, or do any adjustment at the valve, you have a switch right there at the valve or at the system that they can do. Aquastat, this is basically, we add this as a standard. One is an extra layer of safety. I know some people, the Aquastat, some people like it, some people don't. We include it, and there's actually a reason that I'll get into a little bit later of why we include it as another layer of safety. The pump, again, guys, we're not pump guys. We just basically put on there what is specified, or if they don't have a specification, if they have just general foot ahead, GPM, some of that information, we can choose a pump for them that fits those needs. So again, those three things really haven't changed from our standard manifold system. What we really want to talk about is the control boxes and then also the automatic return valve. Let's go ahead and jump into the control boxes. At the top there, you'll see a 3D model of our deluxe box, and then a 3D on the bottom, a 3D version of our basic box. If you will, and pun fully intended, these are basically the brains of our C-valve system. We talked about the four-way protection. Basically, the nice thing about that is you really, if they want to, they can plug this system into a battery backup system, but it's not really a requirement because there again, whether you have power or not, we're still providing tempered water. So if they lose power to their building and they don't have this plugged into the battery backup system, again, they're getting tempered water. Lockout, tagout, if you look on both of these boxes, there is a key location where they basically can, before they can do any setting or adjusting of the valve, they basically have to insert a key and turn it to the set position. Or on the basic, it's on-off. Some pretty basic there. I think a lot of you are familiar, a lot of you have been in mechanical rooms where you walk in there and everything in the mechanical room's been touched, adjusted, but you look at everybody that's in the building and nobody's touched anything. So, or nobody's claiming that they touched anything. So what we've done here is basically try to keep those unauthorized adjustments being made. They can go up there all they want and push those buttons and nothing will happen unless they got that key in there, turn to the set mode of the system. Remote monitoring adjustment, again, guys, that's kind of the whole idea behind this thing, and the reason I think these systems are out there is because the idea you can remotely monitor and adjust these valves from a desktop laptop where the guy's, sitting, the facility manager sitting in his office. One feature we have that our competitor doesn't have is the data logging capabilities. Basically, guys, we can record basically what happens in that system from, for 1 day, 1 week, 1 month, 1 year, 10 years. We can record all that stuff. Basically, as they're monitoring, it basically is recording that and storing it in the system, which then can be downloaded and exported into an Excel spreadsheet where they have a permanent record of what has happened in their system. The nice thing is about that, for liability standpoint, if somebody says, hey, I got scalded in your building, they have a permanent record of what that temperature was, of when that person was in the building. Secondly, anybody makes any adjustment to the system, that is time and date stamped as well. So if the third shift maintenance guy goes in there and makes an adjustment and then denies it later, guess what? That is time stamped on there. So there's some accountability there in the system, some liability, I think, with the data logging. And we are aware of some municipalities that require nursing homes to constantly monitor and log their temperatures throughout the day. So again, this is an easy way for them to do that without having to send somebody down to the system. It's automatically data logged. They can then download that or export it every day, have a permanent record that they can store on their network, in a file that basically says these were our temperatures throughout the day. BMS integration, basically we have 3 protocols that we can are compatible with. Modbus, basically out of the box, this is a Modbus unit, but we can attach gateways to these that will convert that signal to a LongWorks or BACnet signal to work with basically those type of BMS systems. We are aware of BACnet. There are a couple different versions of BACnet or different protocols within BACnet. I think we also have those covered. But by all means, if you hear anything else out there that's in the works or somebody else is working on, please, by all means, either forward that to myself, Gary, or Cameron, so we're aware of it and can make the necessary adjustments to our system. The automatic return valve, we will talk about that in a minute. Basically, where we're thermostatically balancing the system rather than mechanical. Pre-pipe solution. Basically, again, guys, just like our manifold system, it's a plug-and-play system, easy to install, a few headaches. It's all pre-piped at Lawler. We're responsible, and we know it's piped the right way. Again, like I talked about before, valves still serviceable by you guys or a plumber that's familiar with our valves. It's still a mechanical device at the end of the day. The one nice thing, it's a little different than our competitors. We can adjust the valve at the system without a laptop. Basically, our competitors, you require a laptop with a serial cable. So I don't know how many maintenance guys you know that are carrying around laptops to be able to adjust the temperature, but I don't know very many doing that. As a matter of fact, the funny part was with when we were at the ASPE show, the VP of North American Sales came into our booth, and we were kind of going over it, and I pointed it out that we can make adjustments at the valve with this toggle switches, and he kind of looked at me and goes, "Ha, that's a good idea." Again, I think that is one of the things that, I guess was good that Armstrong came out with their system first, so we could kind of see some of the flaws and some of the things that we can do a little bit better. Again, the system reduces chance of unauthorized adjustments where we can go in and we can actually password protect the box that only allows certain people to come in and make adjustments. And then lastly, the Neptune software package. Basically, that is our BMS for this system. Now, they can use their current BMS system, but we can also provide our Neptune software package that allows them to remotely adjust, remotely monitor, data log. There's alarm capability with that. And basically, it's probably the easiest way for them to install the system seamlessly using our software package that we provide for free. Now, don't tell Bob that we're providing that for free. He thinks we're charging, an exorbitant amount of money for that system. But basically, it comes free out of the box that we can send to them. They can then keep an icon on their desktop or keep that program open and running the entire time. That allows them to do the remote monitor adjustment. We don't then, at that point, with integration with their BMS, a lot of that goes away, and like I said, the seamlessness of the installation goes much better with using our software package rather than going through the BMS. The basic box, real simple, digital readout. Everybody thinks digital, is better than analog. Provide a digital thermometer, digital or electronic actuation where we can toggle switch. We can digitally or electronically remote or adjust the temperature. Really, the only integration we have with a building management system is we can provide a set of dry contacts that they can then plug into the system for an alarm. And that's about all we can do with this box. Now, the next generation we are already looking at, and maybe at the end of the year we roll out with that, is a box that will, a basic box that will be able just to remotely monitor only and still provide an alarm system. So that's probably the next generation, but we really want to get some of these out there first before we really jump into that. And also try to get some other things off our plate as far as projects that we have going on. So those are basically the two control boxes. I want to jump into the automatic return valve quickly. Some of you guys have been around for a while. Remember our 517 under-the-counter valve. And basically, that's what this valve is. We have quite a few of them sitting around. And basically what we're doing is, if you look at this, we're basically taking that valve and we're bringing the return water back in through the outlet of the valve, basically forcing this valve to work in reverse. The hot side of the valve is then piped towards the hot water source, and the cold side of the valve is piped towards the valve. So basically now we're thermostatically balancing the system instead of mechanically with a ball valve, circuit setter, or balancing valve. And basically what happens is, say the valve is set at 110 and this return water comes back at 118. That valve's going to sense that it's over temperature, and then we'll now divert more water back to the valve to lower the temperature in loop. Vice versa, if the return loop is under temperature, it will then divert more water back to the heat source to bring that temperature back up. One thing that we do look at, or the reason we have the Aquastat, guys, is the fact that these under-the-counter valves, and every under-the-counter valve does that, whether it's ours, Leonard, Powers, Bradley, anybody that does these little under-the-counter valves with a wax element, when that element fails, it fails hot, guys. So essentially what will happen is when this valve fails, when that thermostat fails, it will actually start diverting all the water back towards the tank. And so having the Aquastat there, which I know some guys don't like, is now adding another layer of protection in that system. In addition to that, and I'll finish up here fairly quickly to pass it on to Cameron, if they ever want to adjust the temperature of this valve, it is very difficult to do. I don't know if any of you have ever tried to adjust the valve in an under-the-counter situation, but it makes it very hard to do. So if they want to say their current is 110 and they want to go to 115, call us up. What we'll do is we'll factory set this at 115. You can see here it's with unions on it. And we'll just send you a new one that adjusts at 115. It's fewer headaches for everybody. We know it's set at the right temperature. And there again, we're just trying to make life easier. You know, for us to send you out a $30, $40 valve, you know, it's worth it for us to do that, to make sure it works out right. We kind of got a little bit into talking about the basic, being not able to remotely monitor. We have come across a thermometer that we are now offering. We're calling it our Triton thermometer. Basically what this is a non-digital, non-electronic, so no power is needed for this. It's a thermometer, and what we do is we provide a transmitter on the back of here that attaches to this that you can then plug into a building management system. And basically is compatible with any protocol. The nice thing is it can be retrofittable out in the field where you can you know, put this in. They now have access or capability of remotely monitoring. You can put it on the outlet. You can put it on the two inlets. You can put it on the return line. So, you know, you can tell these guys 4 or 5 of these basically right out of the box, ready to go. Plug and play, off you go. It's a really simple solution. This is basically kind of a response to, you know, the email I sent out about Leonard's BMSI system, where they are basically just remotely monitoring. You know, the list price for that thing is $4,500. They're selling it to a wholesaler for $2,700. We're basically starting this around a $950 list price, guys. The box that Leonard's using, we have one of those here. We know the company that makes them, and they're not that expensive. So this is kind of a good answer to that that you can do. Again, it's not digital, but, you know, at the end of the day, does it really matter when they're really just looking for something to monitor? I'm going to kind of step away now. And what I'm going to do is I'm going to hand over control to Cameron. He's, like I said, back in the system, and he's basically going to show you how kind of all this functions and works in a live situation. Again, I apologize ahead of time for the delay. That is something we were working on. So, Cameron, give me a second here. And you are good to go.
Okay, so Matt's done an excellent job kind of going over a lot of the features and benefits with our new C system, or newer C system for you guys that have already been aware of the system. But you know, real quick, I want to go over as far as what do you get from the package, and then I'll step into what you do as far as how the set point adjustment works, and digging a little bit deeper with some of the features and benefits that Matt mentioned earlier. So if you're talking about ordering a basic C system, you get everything you see here on this green grid, including the grid, of course, minus this white deluxe control box off to the right here. Now, with the deluxe system, you would receive everything you see here on this grid, minus this you see here, at which you would see the deluxe control box in place with the basic control box. So, now that you guys have kind of an overview of what the system includes or what the package includes, let's go over some of the set point for the basic system, okay? And for the basic system, Matt mentioned something about preventing unauthorized adjustments and more of a system process approach to the temperature adjustment. I know a lot of you guys are familiar with, at least from the technical side, of receiving a call and a customer saying, okay, man, the valve, I can't set the valve's not holding temperature, it's not setting temperature, whatever the case may be. And a lot of times your first question, if it's not, well, did you read the set point instruction manual included in the box, is, well, is the recirc pump running? Did you shut the recirc pump off? And a lot of times the answer is, wait, you're supposed to shut the recirc pump off? Or, well, do you guys have sufficient demand on the system? Or is it one shower? Did you open one sink and you're trying to set a 805, for example? So what we've done is we've integrated some sensors that require those conditions to be met prior to letting you make a temperature adjustment. So we'll step through that on a basic control box here. So as you'll see, we have a basic control box system. And on the side of it, it's actually got 5 very simple steps that are, stuck to the side of the box that will help remind you of those steps to include or take part in when you want to make a temperature adjustment. So the first step, you're going to take a security key here, insert the key, and turn it into a set mode. And at that point, you'll see that it's trying to enter a set mode via this green light here, but it's hard to see, but there's actually, this is a flow light right in front of my finger here, and it's not illuminated yet. So it's saying that the flow conditions are not met, so it can't make a temperature adjustment. You can push the toggle switch all you want, but you're not going to see a temperature adjustment. So the next step in the process, step 2, is to turn off the recirculation pump. And we see here the green light showing the recirculation pump will be running had it been plugged in. Since we're not actually flowing live water through the system, we don't want to deadhead the pump. So we'll turn off the recirculation pump. So we still do not have a light here. So the third step in the process is we need to create demand on the system. So I'm going to simulate demand by manually actuating this flow switch here. Once I do that, it's now saying that the flow conditions are met, it's entered set mode, and it's ready to make an adjustment. So at this point, then I could press this rocker switch, and I know it's pretty hard for you guys to see, but when I do that, you'll actually see a red and a green light illuminate on this actuator, which I guess you guys probably can't see via the cam. But the reason we've integrated that is when we take the approach of designing the system like this, in either the basic or the deluxe, we want to make sure that you ask the question, okay, who's going to install this thing, who's going to maintain this thing, who's going to utilize this system? Is it going to be a programmer, electrician, or is it going to be the plumber? And we want the answer to be the plumber. We want it to be very simple, easy to use, easy to maintain, and easy to repair. And when we say that, we've integrated those lights and various other features in the system to make it very easy to troubleshoot. We don't have problems with the system, and we haven't had problems with the system, and don't foresee that. But you always want to keep it very easy to repair, as we have with the 800 series. Taking the bonnet out, and the stack can come out and be replaced, or the bottom plug to replace a piston light or anything like that. Well, those lights help you indicate, okay, is an actuator issue or a control box issue, so on and so forth. So once the point that we have made a temperature adjustment and we've seen an adjustment, which in this case we won't because we're not flowing live water, we could turn this key back into an operate mode, turn our recirculation pump back on, and put the flow conditions as they were before. So turn off your sink, your live, your test port connection, whatever you're using to create demand on the system. At that point, we can take that key out, and at this point, now that's that lockout tagout function or feature that Matt was mentioning earlier in this presentation, in that now we can press this rocker switch all we want, but there will not be a temperature adjustment on this system because it requires the key to make that adjustment. All right, and there's also some alarm functionality as far as linking up to a building alarm system via dry contacts, which can be adjusted through this display here, and a few other functionalities. But we'll leave that to another point in time, and and we'll delve into the deluxe system as far as making a temperature adjustment and move on to that point. So as we cycle over to making a temperature adjustment on the deluxe system, it's very similar as far as just a few steps to make an adjustment and requiring that proper flow conditions are met before it actually allows that adjustment to be made. So, but it is a little bit different in the aspect that on the basic system, you actually physically press the rocker switch and make an adjustment. In this case, the computer controller, or the PID controller, makes the adjustment for you. So in this case, the first step is we're going to realize that there's 4 buttons at the bottom of the display here, and we're going to tell it what temperature we're looking for. In that, right now it's saying that the valve is at 119 degrees. It's supposed to be set for 101 degrees, but it's not into a set mode right now. It's in a holding or operation mode where it just holds its previously set temperature. In this case, that's just a floating temperature that's being simulated since we're not actually running water through the system. So in this case, we're going to press the scroll button once, and it's going to highlight the set point box or adjustment box. We're going to press it again to say we want to make an adjustment to the set point. Let's say we want to set it for 110 degrees now. So I'm going to press the up arrow a few times until I reach 110 degrees, which I know it's hard to see, but you'll have to take my word for it in this yellow box here. I'm going to hit the scroll button to enter that new temperature, and as you can see now, the set point says it's supposed to be 110 degrees. I'll press the page button to back out, and now it's ready to make an adjustment. At this point, it knows now what temperature it's looking for, but it's not looking for that temperature until we tell it to look for that. So now to look for that temperature, tell it to enter set mode. We'll key the switch, or the key switch, from operate to set mode. As you can see, the lights have not illuminated yet, saying that the proper flow conditions have not been met. So in this case, I'll take a step back here and turn the recirculation pump off. You'll notice that there's still no flow lights. In this case, now I'm going to create demand in the system just by manually actuating the flow switch since we're not flowing water. At that point, you'll see the green indicators come on to say it has indeed entered a set mode. Up here, it's actually going to calculate what change needs to occur for it to actually meet or set at 110 degrees from 119. You'll see a little light has flipped on there, indicating that it's trying to cool down the valve. You'll see a red light on the actuator, which I know it's hard for you guys to see, but it's showing that it's actually trying to cool the valve right now. And it will go on about that and do what it takes to reach that 110 degree set point. At this point, since we're simulating the system and we're not flowing water, I know it'll never actually reach 110 degrees. So I'm going to fast forward to a point to where we believe that it's now at the set point. I'll key it back into an operation mode. I'll turn the recirculation pump back on, resume the previous flow conditions, and at this point, now the system is set. I can take that key away, lockout tagout function, and from this point on, this valve cannot be set at a different temperature. You can tell if you would like to set it at another temperature, but you cannot initiate that set mode or set function. Okay. Now, there's also some other functions as far as graphical displays and things like that that we can get into if we have some time. But at this point, I'm going to step over to making a remote set point or set point adjustment with our Neptune software. So I'm just going to select a shortcut on the desktop, much like what you would have on any desktop or machine that you had that you would like to install the Neptune software package on. And this package is a very simplified version of a complex building management system, such that it makes it easier for the user to understand what is my mixing valve system and how do I monitor and adjust it. And it's also a very cost-effective solution for those that have not stepped into a full building management system yet, but would like some of the remote functionality and remote monitoring capabilities. So if you look on the lower right-hand side of the screen, you'll see our Neptune package, our Neptune software main page. And from this point, you'll see that you have select the device, a couple links at the top page here, and some various boxes. So first, we'll start out with an instruction tab that it kind of steps you through the 5 main steps or simple steps to make an adjustment. It gives you a couple notes at the bottom, you know, as kind of like we're running on a slow Wi-Fi connection back here, so you might see some delay between the point in which I tell the Neptune package to make an adjustment in the valve actually make an adjustment. But that's just something with being on a Wi-Fi connection with a poor Wi-Fi connection, things like that. You know, a lot of things that a plumber may not think of right off the bat, but it kind of helps ease his mind as far as making sure that everything is operating. There just might be a slight delay, things like that, depending on your system. Also a help box that takes you to the website and various individuals to contact if you're not able to figure it out from those few easy steps there. And over here you'll see a selected device. So what this allows you to do is say, okay, well, maybe I'm in a hospital and I have an east wing, a west wing, you know, various different C-valve systems in the same complex, and I want to only adjust one of those systems. So at this point you can cycle through and say, okay, well, which C system would I like to adjust? In this case, I'm going to select the one right behind me so I can easily allow you guys to see what the system is doing as I make an adjustment on the Neptune software. And, you know, pardon the Wi-Fi connection, it's going to take a second to connect to the device, or connect to this particular device. And then it will allow us to make an adjustment. And you'll see here it's going to give you the temperature readings of your mixed outlet, hot inlet and cold inlet, so you can make sure to have that 20-degree temperature differential between your set temperature and your incoming temperatures. You'll see that this system in particular has been set to have a range of 90 to 120, standard range for a standard stat. It's currently set at 110 degrees, even though the valve's actually at 119. Like I say, just because it's a simulated temperature fluctuation. You'll have your pump mode selection and your controller mode selection lights here. So in this case, we can see the pump light for the pump is on, via this green light, and the green light you can see on the power switch box behind me here. So what I'm going to do is I'm going to say, okay, in this case, the first step we're going to do is we're going to turn the recirculation pump off. You'll see that the light has gone off on the box, and this light will go from green to red after that delay has alleviated. We'll now simulate demand on the system by manually actuating this flow switch, or like you would via opening up a test port, turning on some labs, whatever it takes to actuate that flow switch. In this case, now we've seen the flow conditions are met. We're going to go into an operate mode, in which case you'll see both of these lights go green, and the two lights on this controller go green here in just a second after that delay. There we go. I guess it didn't click the first time. Now we've seen that green lights enter into a set mode. It's confirmed that it's now in that set mode. We're going to say, okay, well, it's currently at 110 degrees, but we might want to set it for 105 degrees. So we'll hit the Set Temp button. You'll see that on the actual NanoDAC display here, in the top left of your screen, it's gone to 105 degrees. The Neptune system has confirmed the 105 degree set point, and now it's going to make the needed adjustments to reach that 105 degree set point. In this case, it's simulated, and I know since it's not flowing water, it will never actually reach that temperature. I'm going to go ahead and fast forward to a point where we felt that it was at the proper temperature, and enter it back into an operate mode. You'll see the lights on the display have now gone black again. It's entered into an operate mode. It's not into a set mode. And at this point, we can turn the pump, recirculation pump back on. You'll see the green light is illuminated here. And we'll cycle the flow conditions back to what they were before. So at this point, we've made a remote temperature adjustment. We can continue to monitor. We can cycle through via this select device to a different NanoDAC, or we can close it out. Now, what we also have is an alarm functionality here built into the display. So it's kind of grayed out right now, being that it's not an alarm condition. But if it were to reach an alarm condition, much like an AVOS or whatever else, it would actually flash a large beacon of light across the bottom right-hand corner of your screen and show that it's an alarm condition. And you can quickly see that, okay, well, the mixed temperature, outlet temperature has exceeded whatever your alarm set point is. In this case, it's likely to be 125 from a factory default. And then you could send the appropriate individual to go correct or make a corrective course of action to fix that. At that point in time, we can say, well, we're done with it, we're leaving for the day. I'm going to disconnect from the system or from the server, and I can close that system down. Now, we also have, I'll flash through real quick here, a couple of other ways of data logging. If you can see, or displays for the data logging, whether it's just the temperature, whether it's bar graphs, line graphs you'll see populate here, whether it's horizontal or vertical, and back to your main display here. And with those graphs, as Matt said before, you can data log that information for a very long period of time, whether it's seconds, minutes, days, weeks, months, years, and it also timestamps each time when an individual logs in. So something like a nursing home, as Matt mentioned earlier, where the on-staff personnel has to go through and document or have his rounds and document the outlet temperature of the valve. Well, he can actually have a password. In this case, they have three: an operator, a supervisor, and an engineering password. And in this case, you could give him, an operator or supervisor password that he can walk through and log in, and it will actually timestamp and say, okay, Joe, the maintenance guy, logged in at 3 o'clock on Tuesday to confirm the temperature, or to make a security revision, or to note that the temperature was running high or low, or whatever else you might want to note in that system. And it will actually permanently log that and date stamp it in that graph that we saw here earlier, whether it's on the display, pulled out through a USB, or viewed remotely. So I know that was kind of a quick overview of just some of the functionality of the system, but do we have any questions or any thoughts on the system?
Any questions,
points
guys?
to clarify?
Wait, I got on mute. Everybody, hang on. Anybody have any questions or anything? Okay. I know some people asked some questions, during the presentation and everything, so in the chat area.
Nobody has a question.
But nobody has a question about
Come on.
anything they've seen today?
Everybody's already got one sold.
All right. Guys, we're basically wanting to really incentivize you to get these out here. I mean, we want basically get as many of these out there in the market. They want this to be a pain in the butt in Armstrong's pants, but also be a really get these out there, because I think it works. We offer something that they don't, that really nobody else is offering, and so around here, kind of cash is king, and I'm sure it's that way with you guys too. So we've laid out an incentive program, and I'm going to have a form up on Lawler Rep that you guys can use, especially for this top one. Basically, you get a C-valve specified. I'll ship you for every specification you get. I'll send you a $50 Visa card. And all I need is a copy of the spec, the engineering firm, the engineer, who the engineer is, and that person's contact, phone, email, and everything. So for every specification you get, I'm going to send you a $50 Visa card. So if you get 3, I'll send you a $150 one. And then to kind of take it up another notch, for every C-valve order that every order you guys place for the deluxe, I'll send you a $200 Visa card, and then for every basic, $100. Basically, that's going to go from today to the end of the year, and basically, even if you turn in the PO on December 31st, 2013, it'll still qualify. So, we really want you guys to get out there and kind of push these things. I know in some markets it's been a bigger deal than in others. I think a lot of it depends on who the Armstrong rep is, and who, and how motivated they are to sell this system. So, like I said, I think there's some real opportunities. Another thing I want to point out too is the fact that we have gotten fairly aggressive with the pricing. We just sold a parallel C-valve system, which basically would be 2 valves with 2 control boxes, 1 for each valve, down in Florida. So, again, I think there's some opportunities out there. Just to kind of let you guys know, again, this, one of these today is going to be on the website or on Lawler Rep, where you can share it with guys that have been able to attend. or maybe even some engineers, and then also this PowerPoint presentation that we have as well, which is somewhat interactive. Also, we will be offering, if you want us to do this type of same thing with an engineering firm on a lunch and learn, we can do that as well. This is fairly easy to set up. We're going to work on improving the video feed, so we're not so much delayed with a little bit better quality. If we need to come out. Also, guys, if you give us enough advance notice, we can actually ship that C-valve system that Cameron's standing in front of to your location and basically have an open house. Invite engineers, or anybody you think be interested in that, and let's do an open house or a big lunch and learn with a bunch of different people. Let's get creative out there on marketing this out there. One thing, a question that kind of came up in the last session is the fact that doing a training video, and that's going to be the next thing we do, where we do basically a training video where Cameron goes through how to set the valve, how to use Neptune software, put that on a DVD, and send that out with the system. Grant can testify that he had one of these in his area, and the startup was a little bit more difficult. That is one thing we're also willing to offer as well. If need be, as a ultimate last choice, if you need a startup, you sell one of these and the end user is insisting on a startup, either Cameron, Gary, or myself, or a combination of us three, would be willing to come up or to your area and actually do a startup where we go through training, make sure everything's connected, and so kind of give everybody that warm, fuzzy feeling before they open up the building to everybody, and we make sure it works. So maybe initially that's the best way we go about it, but once everybody gets comfortable with it, maybe slowly back off. But that is, again, an option that we're willing to do, and like I said, that just kind of shows our commitment to this system and to you guys to make sure you have all the tools necessary. And like I said, be creative in getting the word out about this and getting it specified and getting it installed. You got a program you want to do on your own with the support from us or whatever, you want to do something special, by all means pick up the phone, call us, and we can discuss it. Like I said, we're creative and we're dedicated, and we want to get as many of these out there and kind of force Armstrong's hand a little bit to do something a little bit better. And so we can step it up a notch. So, any questions, guys? If there's no questions or anything, we'll go ahead and end.